Hello and welcome. In this video I'm going to be teaching you the linked list data structure. We'll be covering the basics of this structure, and in later videos we'll cover more advanced topics. So a linked list is a type of data structure that allows us to store values of really any given type. There are a few advantages to using a linked list, as opposed to other data structures like an array. So here we have a side-by-side view of both of the data structures. At the top we have the linked list, and at the bottom we've got the array. We'll quickly familiarise ourselves with the array before we go into the linked list. So at the moment we've got 4 values of integer type, 4, 6, 7 and 9. And when stored in memory, they are back to back, i.e. they are contiguous. And this is great because if you want to access the values, you can do so just by using the index value. So the value 4 can be retrieved with the index 0, 6 can be retrieved with the index 1, 7 can be accessed with 2, so forth. On the other hand, if we take a look at the linked list, you can straight away see that the containers that hold the value, they're completely spread out. And this is the nature of this data structure. They are holding the values in their respective container, but they're not stored in memory contiguously. They are spread out dynamically in the heap, as opposed to the array, which would be stored on the stack. Containers are connected to each other. So 4 is connected to 6. 6 is connected to 7, 7 is connected to 9. And it does that using a pointer or a reference to. So the container 4, or the container, is holding the value 4 and a reference to container that's holding the value 6. And that repeats all the way through the linked list. And that's quite useful. Here is just an example of how they would look in memory. You can add values to the end of the linked list. We'll go into the implementation and the various operations you can perform on both data structures, but you can, of course, add values and it would continue its principle. The linked list, you do not have access to the index. You don't know its position. It's not stored in a single block of memory. It's scattered around. So that makes accessing a value rather strenuous on the time complexity. And that does make the access to a value linear time, purely because you have to traverse the whole data structure. And then eventually you will find the value. It's a lot more complex as opposed to the array that's of constant time complexity. And it's just a lot more simpler, less performance constraints on the array. One point to mention is that the linked list is very useful and serves as a building block for other more complex non-linear data structures such as a graph or a tree, whereas a traditional array does not have that ability. You can also use the linked list to serve as the backbone to a queue, again useful depending on the problems you're trying to solve. We will now go into the implementation of the linked list using the Python language. Okay, so we're going to begin writing our implementation. The implementation will come in 2 parts. We're going to write the object that will represent the container or the node, and the linked list itself, so the backbone to this, to the data structure. So first off, we'll begin with writing a class for the node. So we'll define a class node. It's going to have 2 values. The value itself it's storing of any given type, and a pointer, which is with reference to the next node in the sequence. So we will create a constructor method that will initialize 2 values. In fact, we can call this next. Okay, and the next stage we want to do is be able to change the pointer, or in this case the next node in the sequence. So we'll create another method called setPointer. Okay, the setPointer method will take a value of node object, and we'll store that in self.next. And we can also add a method, an inbuilt method called repr, which will return a printable representation of the value. And there we have it. That's our node object. Okay, so the next phase is to write the linked list. So let's define a class. It's going to have a constructor, a default constructor, and it's going to take a head node. So we can just call this head. And this gives us the ability to start the linked list. So as part of the linked list, we want to perform many different operations. In this tutorial, we're going to cover the insertion at the start of a linked list, the insertion at the end of the linked list, and a traversal to print the values. So let's start writing the insert node at the start. It will take a value. We will need to create a node object. And now we will need to make the new node the new head. So this will connect the new node and the head together, and then we want to remap the head to this new node. So here we are going to move the head to the new node's pointer, and that way the head moves to the right by 1. And then we will change the head value to our new node, so that it's at the start. The next phase is to write the method for inserting a node, but at the end of the linked list. Again, we'll take a value. We'll also create a new node object. We want to check if there's a head. If there's not, we want to then put our new node as the head. Otherwise, we'll proceed with traversing the linked list until we get to the end, and then we will append our new node to the end. So now we will find the node at the end because its next value will be equal to none. And then once we're at that phase, we'll connect that value, so current.next, to our new node. So now let's import our new linked list and our node. And then we want to instantiate the linked list. And now we want to create some nodes. Now we have our list and our nodes A, B, and C. We can now connect A, B and C together using the list. So we can insert a node at the start if we wish. That could be node A. And then we can insert node B to the end. And we can also insert node C to the end. So you can see they are connected together. And if you're to see the values, we've got 2, 5 and 9, which was the order of creation. The next part of this implementation is to implement the delete node at the end. So we can do that by first defining our method and traversing the linked list all the way to the end, and then just deleting that last value. What this code will do is have a temp variable that will begin at the head, because that's our starting position, and then while the temporary position next dot next, so the value in front of the object we are pointing to, while it is not none, we continue traversing, and when it is none, then that means we are second to the last position, and therefore we can change the pointer of the next to none, and that will get rid of this next pointer here. Finally, we will write a method to traverse the linked list. As part of this traversal, we will print each value. Of course, starting at the head. And there we have it. So now we can test out our new traversal method. There we go. We can see the values 5 and 7 are from the nodes are printed. I hope this video was useful and taught you how the theory and implementation of linked lists work. For more videos like this, please leave a like and subscribe. For content that you would like to see in the future, please leave a comment down below.